are container adapters. That is, they take an underlying container and adapt it into a first in, first out, or FIFO queue. Let's make a working copy of queue.cpp and see how this works. I'm going to bring this into the editor here, and let's compile and run it and take a look at what it does. So up at the top here, you see I'm including both queue header and the list header because a queue is a container adapter and I'm using a list as the basis for my queue. The underlying container must support front, back, pushback, and pop front. And a queue does not have iterators. If you need iterators, you may want to use the underlying container directly. So let's take a look at how this works. We're taking a list here, and we initialize this list from an initializer list. And again, this is a C++11 feature. And for other ways to initialize a list, you can see the movie on lists here in this chapter. And then I take that list and I use it to copy construct a queue. And so on line 10, we define the queue, and the queue takes two types. The first type is the underlying type, so it's the type of things that the list is made up of. And the second type is the container that's being adapted. In this case, that's the list. And then the name of this queue is QL, and it's initialized with the list LI. I'm just going to go ahead and minimize this over here too so we can see all the way to the end of these lines. And if I run again, then we'll get our little console. I can move this down to the bottom and we can see all of that. So we initialize our queue from the list, and then we call size on both the list and the queue. And you can see the list has 5 entries and the queue has 5 entries. So the queue is a copy of the list. It's not a reference to the list. And so when we pop all the elements out of the queue will be empty and the list still has its 5 entries in it. And so here we see the list has 5 entries, the queue has 0 entries, and there's our popping all from the queue. And you'll notice that when we pop from the queue, pop does not actually return the contents of the element that is popped. And so you have to get the element first from front and then call pop. And there we list the contents of the list after QL has emptied. And you notice I'm using the auto keyword here, and that's a C++11 feature. Otherwise, we would need to declare this iterator based on our list type. I believe our list is a list of integers, so it would look something like this. And auto is just a whole lot easier and less prone to error than that. Now here we are declaring a queue in a different way. Now you remember earlier we declared our queue based on the list container. And so it was a queue of ints based on a list of ints. Down here, we're just declaring a queue of strings. And the default type of queue uses a deq object. And you notice I pronounced that deq instead of deque because deque might seem like a verb. It means to remove things from a queue. But actually what this object is, it's a double-ended queue. And so the consensus is that we don't pronounce it deque. We either spell out deq or we call it a deq, which is how you would pronounce deq if you were to try to do that. So we'll cover deqs later in this chapter. And yet all you need to know here is that the default queue uses that object. It's a double-ended list. It's a type of container that was designed pretty much for this purpose. And so we've got a queue of strings and we push some strings onto the queue, 1, 2, 3, 4, 5. And then we have the size of it, which is 5. And then we pop all of them from there and we can pop them this way. While it's not empty, take the front and pop, and then the size is 0. So that is pretty much how queues work. A queue is a container adapter that adapts an underlining container to a first in, first out FIFO queue. Now let's see if we can get our screen back to the shape it is normally in. And we'll delete our working file